again to another video in this series. This is the Mathematics, your complete online school of mathematics. And as you know, what we do here is break down mathematics, making it easy for you to understand, to learn, to follow, and to become better. I'm Pendulum, your tutor on this channel, and you're welcome. Please, if you're new, don't forget to subscribe to the channel so we can keep growing together, reaching more people with the gospel of mathematics. And welcome. We've been looking at polynomials for the past few days, and today we are going into our focus on that polynomials, which is factor theorem and remainder theorem, which we'll get to in future videos. Now, factor theorem and remainder theorem are important part of operations with polynomials, and this factor and remainder theorem helps us to work with cubic polynomials. In the last video, we looked at degrees of polynomials, and we saw that linear polynomials have only one variable, and they can be solved easily. Quadratic polynomials linear polynomials have the highest degree of their variable to be 1. Quadratic polynomials have the highest degree of their variable to be 2, and they can be solved by various means, which we have done on this channel. And this factor theorem and remainder theorem will help us to solve cubic polynomials whose highest power is to the degree of 3. All right, so welcome. Let's go get started. Don't forget, copy the link of this channel, share it to your friends, to your guardians, to your wards, to your children, to your brothers, sisters, whoever you know that needs mathematics. Put it on your WhatsApp status so that they can see it, they can come and learn, and become better at mathematics. Now, the factor theorem is a simple theorem. It states that if f of x is a polynomial, here we are assuming it's a degree 3 polynomial or a cubic polynomial. But if f of x is a polynomial and f of a is 0, then x minus a, which is a linear function, is a factor of f of x. What this simply means is that f of x is a cubic polynomial. So for example, you see what we have here in example 1. F of x is equals to x cubed plus 2x squared minus 5x minus 6. You can see what we have here in example 1. This is a cubic polynomial. This is an example of f of x. So if this is a polynomial and f of a is 0, that means if I divide this by a linear function such as x minus 2 here, x minus 2 is a linear function or a linear polynomial. If I divide this cubic polynomial f of x by this linear function x minus a and I get 0, simply put, if f of x divided by x minus a is equal to 0, what it means is that x minus a is a factor of f of x. So the factor theorem simply means that how do you know that a linear function is a factor of a quadratic function? Simply divide the cubic polynomial by the linear function, and if there is no remainder, if your answer is 0, that means the linear function is a factor of the cubic function. All right, remember a linear function has just one function, like this x minus 2. A quadratic function is made up of 2 different functions, so maybe x minus 2, x minus 2. If you open it up, if you expand the two brackets, you get a quadratic function. Okay, and a cubic function like this will be made up of 3 linear functions. What do I mean? You have x minus 2, for instance. This is one linear function, and this gives you a linear polynomial. If you want to get a quadratic polynomial, you have to multiply this. You have to multiply this by another linear polynomial. So x minus 2 times x minus 3 will give you 2 linear polynomials or 1 quadratic polynomial by the time you expand this bracket. Now, if you want to get a cubic polynomial, you have to now multiply this again by another linear polynomial. So if you multiply 3 linear polynomials like this, it gives you a quadratic polynomial here with the highest power to 3. Of course, x times x here ultimately will give you x cubed. All right. So if you divide this, for instance, x cubed plus 2x minus 5x, if you divide it by x minus 2 and there is no remainder and you get 0 as your answer, what it tells you is that this linear function x minus 2 is a function of the original cubic polynomial. So I hope you can understand that. If you understand that, then that is one key thing to take note of. All right. So whenever you hear or they tell you that a linear function is a factor of a bigger cubic function, what they are trying to tell you is that there is no remainder if the linear function divides the cubic function. There will be no remainder. All right, and that will help you as we go on, as we do more videos, solve more questions. You will see where that comes into play. But just understand that if a linear function divides a cubic function without a remainder, that tells you that it's a factor of it. It's not even only a cubic function, even a quadratic function. If a linear function divides a quadratic fraction without a remainder, that means that linear function is a factor of the quadratic one. All right, it's like saying if 2 can divide 4 without a remainder, that tells you that 2 is a factor of 4, right? If 5 can divide 10 and there is no remainder, that tells you that 5 is a factor of 10. That means 5 can go into 10 and there will be no remainder. So the same thing applies here, only that here now we are talking about polynomial or polynomial expressions, but it's still the same basic principle as your elementary mathematics. If this linear function x minus 2 can divide this cubic polynomial x cubed plus 2x squared minus 5x minus 6 and there is no remainder, that means this smaller one, this linear function, is a factor of this cubic expression. So now let us solve these two questions quickly and see what they will give us. We are told to verify example 1. Verify that x minus 2 is a factor of this. So how do we check if x minus 2, this function, this linear function, is a factor of this cubic function? And like we've said, the criteria for this to be a function of this, for x minus 2 to be a function of this cubic polynomial here, is that it must divide it without a remainder. So we are going to check it by long division. There's a shorter method of doing this, which is what the remainder theorem is all about. But I won't teach you that now until we get there. I believe it teaches students the proper way to do something, and after on, we'll now look at short methods. So let us do this by long division first of all. Remember, we are asked to verify if x minus 2 is actually a factor of this. So if x minus 2 is going to be a factor of this cubic polynomial x cubed plus 2x squared minus 5x minus 6, it means that x minus 2 must be able to divide it and you get 0 as your remainder. Alright, so now how do you divide polynomials like this? Now the key to dividing a polynomial like this, you use the variable x to divide each of these terms of the cubic polynomial one by one. Right? I'll take it again. You use this variable here, x, only this x, to divide each of these terms of the cubic polynomial. That's this one under the division sign. You divide each of them one by one. And then the answer you get, you use it to multiply everything outside this. Now let's do it step by step so that you follow what I'm doing. First thing we do is this to this. All right. So we'll say, let me use a different color so that probably it will not confuse you. So first of all, we'll say x cubed divided by x. That's the first thing we do. All right. So of course, x cubed divided by x, you'll be left with x squared. All right. It will cancel one of the x, right? So if I divide x cubed by x, I get x squared. Then the next step is to use this thing up to multiply. I use this x squared up here to multiply this. I use this x squared up here to multiply this and to also multiply this. All right. So when you're dividing, remember, divide only by x, by the variable. But when you get your answer, use it to multiply everything outside this division sign. All right, so let's go. X squared times x should give you x cubed, right? Sorry. All right, so x squared times x will still give you back x cubed, of course. And then x squared times minus 2 is minus 2x squared. X squared times minus 2. Of course, if you're dividing, if you're doing log division, you know that you have to keep subtracting. So this is minus. Now x cubed minus x cubed, 0. So that one goes, right? Please follow what I'm doing. X cubed minus x cubed gives you 0. So that one has gone. Then now I have 2x squared minus 2x squared. Okay, 2x squared minus 2x squared. Of course, minus times minus is plus. So I'm going to have 2x squared plus 2x squared. And what will this give me? 4x squared. Right? Please follow what I'm doing so that you don't get lost along the way. So I'm going to get 4x squared. Alright, so I'm going to get 4x squared. Now, I bring down this remaining 2 here, of course. Just the same way you were taught to do long division. So I bring down minus 5x and minus 6. Then we go again. The same thing, we repeat it. Again, remember that you divide this term by this. Alright, just this, divide by x. the number, the constant, has no business in the division. The constant is only used when you're multiplying the answer, not for dividing. Take note of that. All right. So now we now divide again. 4x squared divided by x. 4x squared divided by x. Of course, x will cancel one x here. So we'll be left with plus 4x. Right? If I divide this. Now again, we are going to use this 4x to multiply everything outside. So again, I'm going to use this to multiply this. So 4x is going to multiply x and it's going to multiply minus 2. Same process, just repeat it. Now 4x times x will bring you back to what? 4x squared. Of course, right? And then 4x times minus 2 is minus 8x. 4x times minus 2. Plus times minus is minus. 4 times 2, 8, and then x. Again, we'll subtract. And if we subtract here, then 4x squared minus 4x squared is 0. So these two will cancel out. 4x squared minus 4x squared will cancel out. Then I have minus 5x minus 8x. That's for this side now. Of course, this will give me minus 5x minus 5 minus plus 8x. Alright, and if I resolve this, I'll end up with 3x. Right? 8x minus 5x. And I can bring down this one, minus 6. Alright? So we now have last step, 3x minus 6. Again, we'll do the same thing we've done before. So we are going to do the same thing again. Do the same thing again. So again, we are going to again divide this one by x alone. Please remember, when you're dividing, only focus on the variable. When you're dividing, only focus on this variable x. Alright? Only focus on the variable. Now, 3x divided by x is going to give you what? Just 3, right? Because x will cancel out x. So plus 3. Now we want to multiply. This is now where the constant will come into play. So we use this 3 to multiply everything here outside the division sign. So 3 is going to multiply everything here. So 3 times x will give you 3x, right? And then 3 times minus 2 minus 6 minus and then 0. Because 3x minus 3x is 0. And then you have minus 6 minus minus 6, which will give you minus 6. Minus times minus is plus 6. And minus 6 plus 6 is 0. So at the end of the day, you can see that after dividing, we're able to find that if the cubic polynomial given to us, which is x cubed plus 2x squared minus 5x minus 6, if we divide it by the linear function x minus 2, we end up having a remainder of 0. And what does this tell us? That therefore x minus 2 is a factor of x cubed plus 2x squared minus 5x minus 6. All right, so that's what we get because we have divided it and we have found out that the remainder is what? 0. So this is one way to verify if a linear function is a factor of a quadratic function or even a cubic polynomial, a cubic function, as in this case. Use division, and if you divide it, you should get 0. If you get 0, that means it is a factor. If you do not get 0, if you have a remainder, what that tells you is that this linear function is not a factor of the polynomial given to you, of the cubic polynomial given to you. All right, I hope that is clear. I hope that is clear. Maybe I'll stop here and solve example 2 in another video, depending on how much. I don't want these videos to get so long. So let's stop here. And in another video, we'll look at example 2. But I hope you've been able to understand this. And it's important to understand how to do this division, because as far as you keep working with, especially cubic polynomials, to solve them, to find factors, to confirm that a linear polynomial is a factor of a cubic polynomial, one of the ways you have to do this is by long division. Like I said, there's a shorter way. When we get to the remainder theorem, there's a much shorter way, but you may be asked to verify it using long division, and so you need to know this. All right, and also, even if you're not asked to verify it using long division, if you're asked to solve completely, you may also need this. So please watch this video again. If you did not understand what I did, follow the process. All you have to remember when you're dividing, all right, focus on dividing just the first term in the polynomial. I divided x cubed, I divided 4x squared, I divided 3x, only by the variable here, only by x here. All right, the constant has no business in division. And then when you get your answer, you now use that answer, you get 10 by 10. to multiply everything outside here. So this is now where the constant will be used. You use the answer you get up here, one by one, to multiply everything outside here. Then you subtract, you go down to the next step, you repeat again. All right. So thank you for being here. Remember to share this video, very important. Copy the link, share it to everyone you know that will need it. Put it on your status, put it on Facebook. If you've not subscribed, please do so that this channel can get to more people and they can learn what you've learned and many more to come, and even many more that are on this channel. All right. So subscribe. Drop your thoughts in the comment. Let me know if you have questions based on this. Let me know if you have questions generally on this topic. And let me know if there are things you want me to include or things you want me to improve in these videos. All right. So thank you so much. I will see you in the next.